Hello everyone, this is Anand from an Math channel. In this video, we're going to take a look at a very nice problem related to Vieta's formulas. The problem is, if p and q are roots of this expression, 2x squared minus 4x plus 1, then we need to compute these four expressions. To do that, as I said, we're going to use Vieta's formulas, so if you're interested, just watch the rest of this video. But before we get to Vieta's formulas, let's just take a look at a different idea for solving this problem. The idea is, if p and q are roots of this expression, why wouldn't we take this expression and set it equal to 0, and then solve it for x and find p and q? Because it kind of feels like if we have the value of p and q, it wouldn't be super hard to find p squared plus q squared, or the rest of the expressions we're supposed to find. But I gotta tell you, actually it's going to be super hard to do that. And I'm going to show you why. Let's say we take this expression, 2x squared minus 4x plus 1, and we set it equal to 0, and then we solve it for x using the quadratic formula. So we should get x equals 4 plus or minus square root of 16 minus 8 over 2 times 2, which is 4, which simplifies to 4 plus or minus 2 root 2 divided by 4, which reduces to 2 plus or minus root 2 divided by 2. And that means that p can be 2 plus root 2 over 2, and q can be 2 minus root 2 divided by 2. Which means, if we want to find p squared plus q squared, we would have to square them and then add the result. If we want to find p cubed plus q cubed, we would have to cube them and then add the result. But the thing is, since these numbers are rational numbers with radicals, it's not easy to do that. So, probably, it doesn't make any sense to solve this problem using this method. I mean, if we had something like x squared minus 5x plus 6, which can be factored as x minus 2 times x minus 3, then, in that case, it would make sense to solve this problem in this method. Because the roots are 2 and 3, so we can easily square them, cube them, and etc. But about our situation, since the roots are irrational numbers with radicals, it's not easy to do that. So in that case, it makes sense to solve using this method, but in our case, it doesn't, especially when we know about Vieta's formulas. Now, what are Vieta's formulas? Vieta's formulas state a very beautiful relation between roots of a polynomial and its coefficient. For a quadratic expression such as ax squared plus bx plus c, it expresses that p plus q, the sum of the roots, equals negative b over a, and the product of the roots, p times q, equals c over a. So in our case, p plus q equals negative 4 over 2, which equals 2, and p times q equals 1 over 2. So what we are going to do is to use these two values to find the expressions we're supposed to find. So as I said, based on Vieta's formulas, the sum of the roots equals 2, and the product of the roots equals 1 over 2. And we want to use these two to find p squared plus q squared. How can we do that? Well, we can rewrite p squared plus q squared as p squared plus q squared plus 2pq minus 2pq. Basically, we add and subtract 2pq. Now, the reason we do that is that if we put these three together, we get a perfect square, p plus q quantity squared. So basically, we completed the square, and we get p plus q quantity squared minus 2pq. So the idea is to rewrite these expressions in a form that we would have p plus q and p times q. In order to evaluate these expressions, we would have to rewrite them in terms of p plus q and p times q. And since we know p plus q is 2 and p times q is 1 over 2, we can evaluate this, and this equals 4 minus 1, which equals 3. So this one equals 3. Now, the second one is p cubed plus q cubed. To evaluate this one, we can use two approaches. First, we can factor this as a sum of two cubes. We can factor it as p plus q times p squared minus pq plus q squared, which is the same thing as p plus q times p squared plus q squared minus pq. And we know p plus q is 2, p squared plus q squared is 3, and p times q is 1 over 2. So this equals 2 times 3 minus 1 over 2, which equals 6 minus 1, which equals 5. So the second one is 5. And notice that we also could say, since p plus q equals 2, then p plus q quantity cubed equals 8. And if you expand the left-hand side using the binomial theorem, we should get p cubed plus 3 times p squared times q plus 3p times q squared plus q cubed equals 8. And if we isolate p cubed plus q cubed on the left-hand side, we should get p cubed plus q cubed equals 8 minus 3pq times p plus q. And then this equals 8 minus 3 times 1 over 2 times 2, which equals 5. So again, we found out p cubed plus q cubed equals 5. Now in the third one, we want to find p over q plus q over p. To do that, I'm going to get a common denominator. And to get a common denominator, we would have to multiply both the top and the bottom of the first fraction by p, and the second one by q. So we get p squared over pq plus q squared over pq, which equals p squared plus q squared over p times q. And as we already found out, p squared plus q squared equals 3, and p times q is 1 over 2. So this equals 3 over 1 over 2, which is the same thing as 3 times 2, which equals 6. So this one equals 6. And the last one is square root of p plus square root of q. To evaluate this, first I'm going to set it equal to a, and then I'm going to square both sides. If I do that, I get p plus q plus 2 times square root of p times q, which equals a squared. And then we know that p plus q equals 2 and p times q is 1 over 2. So this gives us a squared equals 2 plus 2 times square root of 1 over 2, which is the same thing as 2 plus 2 times root 2 over 2, which is the same thing as 2 plus root 2. So a squared equals 2 plus root 2, and we want to find a, so we need to take the square root of both sides. And if we do that, we get a equals positive or negative square root of 2 plus root 2. But notice that since this is positive and this is positive, and sum of two positive numbers is going to be a positive value, so a is a positive number, so that means that a must be positive square root of 2 plus root 2. So the last one equals square root of 2 plus root 2. And this brings us to the end of this video. Thank you for watching this video. As always, if you enjoyed watching this video, click like, click subscribe for more content, and don't forget to leave a comment, and click on the notification bell so you wouldn't miss any of my future videos. Thank you for watching this video again. Goodbye, and I will see you later, as always, in another video.